As a data analyst, you know the data. You understand the trends. You know what's going on. But the reality of the situation is that what you know is irrelevant. Your job is to get your findings out in a digestible way for your end user. They are the most important people here. The best way to do that is to create a dashboard. And not just any dashboard, one that allows the users to interact in a way that delivers meaningful analysis in an interesting way. A great tool for this job is Power BI. Power BI is an extensive tool, but I find it helpful to think of it in 3 layers: data, calculations, and visuals. We cannot possibly cover everything about the tool in a single course, and this course focuses on the visuals layer by creating optimal Power BI dashboards. Hi, my name is Helen Wall. I'm a Power BI expert, and I want to show you how you can leverage this software with the aid of some data analytics skills to create fun and interactive dashboards. That includes working with data from open source websites, analyzing trends that lie within that data, creating visuals to communicate the results along with interactive and engaging maps, and finally putting everything nicely into a dashboard and making it intuitive and interactive. So what are we waiting for? Let's dig right into creating dashboards with Power BI. This is it. Here's what we'll be creating. 4 different types of dashboards that are interactive and contain tons of data for people to explore, analyze, and learn from. As you can see, our Power BI project for this course will involve analyzing and visualizing U.S. population numbers. In this project, we are going to examine the U.S. population totals along with the U.S. migration patterns. The focus of this course is on the concept of dashboard design. Good design is not an accident, but rather a strategically planned approach by implementing best design practices. We make decisions such as how to set up relationships between visuals, best calculations to use, deciding what visual best communicates the results, formatting decisions such as color and font, and giving the user interactivity over the dashboard. Simplicity can be a beautiful thing. And when you create a dashboard, not only for yourself, but other people, think about minimizing the number of visuals to 3 or 4 large charts and mindfully adding filters and totals to make it easier to navigate. If you find that a streamlined approach to the dashboard does not meet business demands, think about creating a separate dashboard view or other methods to separate or switch between the visuals. Another important perspective to remember is that your dashboards are dynamic in many ways, and the goals and user interactions this year may change next year, and we want to show flexibility by giving ourselves room to update the dashboards. You'll see this process throughout the course. I even get really picky sometimes and move my visuals around quite frequently. Don't worry, I'll spare you that part of the course. At the end of the day, you want to put yourself in the shoes of the end user. Make their job, whether it's analyzing results, monitoring trends, or making decisions, your driving force. With that goal in mind, you'll already be on your way to creating an exciting, accessible, and consumable dashboard.
Using color mindfully is a great way to create impactful dashboards and visuals for the user. When using colors, I find it helpful to use a limited number of colors so we can easily distinguish between them, being mindful of users with visual impairments such as colorblindness, and trying to incorporate your organization's color scheme into a dashboard, which makes it look more professional and more appealing to users. There are several ways to add colors to visuals. We can add a field to a legend where each category value gets a different color to distinguish it, And we can also use a continuous color scale to relatively compare all the values. There are actually several different kinds of colorblind impairments, but the most common one is the inability to distinguish between green and red. Because people with this visual impairment cannot see red light, if you look at the protanopia and deuteranopia color swatches, conversely, tritanopia cannot see yellow light. Notice that across all three colorblind impairment examples we see, the color palette for orange and blue still allows these viewers to easily distinguish between the colors without too much work. I find that adding gray to the mix for these colors creates a nice color palette usable across all kinds of color schemes, including using colors to identify legends and also for color scales. Within Power BI Desktop, we see a standard set of visuals when we open up the application, such as bar charts, line charts, and several mapping options. Some of the visuals that we will be using, however, are custom visuals that we need to import from the Power BI store, or you can create your own open source visual if you know how to. Within the Power BI Visual Store, some of the visuals are created by Microsoft, and some are certified from outside vendors. In the store, we see the visuals available for Power BI. Most of the visuals are free, but some you do have to pay for. You can search for specific chart names or filter by chart types. Microsoft constantly adds new charts, so be on the lookout for new visuals. And also, some of the visuals you are currently using may not be supported any longer. If you are looking to explore these options, it is well worth spending time looking for visuals you may want to use that are out there. Within the Power BI store, we can download the visual by selecting Get It Now, hit Continue, and then selecting Download for Power BI. The extension for these files is .pbiviz, and this is what Power BI reads as visuals. Then in Power BI Desktop, select to import from File by clicking on the ellipsis next to the standard visuals. Click on Don't Show This dialog box again and hit Import. Now we go to our Downloads folder and select the PBIViz file we just downloaded. We see OK, indicating that this has successfully imported. We can also import it directly from the Marketplace by again selecting the ellipsis menu, selecting Import from Marketplace, and then we can search for or look through the list of potential visuals. You will need to be signed into a Microsoft account to get these visuals, so be aware of that when you start setting it up. We then just select the Gantt chart, hit Add, and there we see that we don't have to download the PBIViz and we can directly import it into our Power BI desktop file. Our data for this Power BI project comes from several publicly accessible U.S. government online data sources. The U.S. Census conducts a survey of the entire U.S. population every 10 years. In the U.S. Census website, we download the data for all the populations for all the counties and states within the U.S. from 2010 until 2018. I provided a copy of these files and the other ones I will show you in your exercise files for this video. Because the U.S. Census is only conducted in 2010, the remaining 7-8 years of the decade are estimated numbers, and you will see this when you open up the file. If we want to get other years of data, the U.S. Census gives us access to this, but it comes in separate sections and different kinds of formats, and parsing it together can be a pain. The National Bureau of Economic Research created a consolidated population data set by county and state name all the way back to 1970 until 2014 in a single file of data. We download the county population CSV file we see on the screen. Next, we can obtain the migration pattern data that will show the flow of people between states and outside the U.S., the foreign migration, by year from the IRS. This data is based on addresses where they file their tax returns. We see in their website that we have access to many years of data, but for the inflows and outflows, the best place to find the data is the migration data from 2011 until 2016. During this time frame, the IRS updated their own methodology to use more accurate numbers or give us more accurate numbers, and we can get the data for these years by clicking on the hyperlinks we see on the screen. We go into each time period and download the state-to-state outflow and state-to-state inflow for each of these time periods. We need to map out the GeoIDs for the county populations to the correct county and state names. And we do this through the 2018 GeoID file provided by the U.S. Census. The link on the screen will take us to a download where we can access the Excel file. You can also link up the URL path as a web connection, but we're going to reference the downloaded file to be consistent in case anything changes in coming years. You can find the GeoID ID file in your own exercise files if you were following along. In the U.S., major metropolitan areas typically contain more than one county, and in several cases, multiple counties. And using this link we see on the screen, we can map the GeoIDs that contain the state and county information to the major metropolitan areas. This is a URL link, but for the sake of consistency, I downloaded them to a text file located in your exercise files folder. This saves having to reference the specific web page in case something changes in the future. After downloading the data, we need to bring it into Power BI using the Power Query Editor. Notice that we are using Power BI file 00_06_begin. We use multiple queries within the Query Editor window. For all of these queries, I connected them up to the file paths for the downloaded files you will find in your data folder. I then used transformation steps to shape the files and the data sources into usable data tables. Those of you following along can either download the files and perform the ETL processes on them yourselves, or you can follow along with me and update the links to your own Power BI desktop file to match the locations of the saved data sets. I connected to the U.S. Census population data from 2010 until 2018 in one query, and then I connected to the National Bureau of Economic Research data in another query. After using transformation steps to make both these queries separately usable data sets, I joined them together using the append functionality, which creates a single query as a consolidated data table. To update these data sources and the other data queries in the query editor, you will need to click on the source step in the applied steps list. This opens up a dialog box where you want to update the file path to the file path you use for your own data set. You then hit OK. The rest of the applied steps will work the exact same way as you see on my screen, as the data source is the only step you need to change. You will then update the file path for all the queries in this query editor window. Notice that the consolidated population data set contains 3 columns: population, year, and GeoID. The GeoID is not much help to us by itself, but it serves as an identification code used by the U.S. Census to tell us the related county names and state names for each of these IDs. One additional step I added to this query was that Dade County became Miami-Dade County in 1990, and this is the biggest metropolitan area in the state of Florida. I updated the GeoID for Dade County to match that of Miami-Dade County by replacing the GeoID with the current GeoID. This is because we want to make sure we include these population numbers in our analysis. The GeoID we see here links up to the GeoID for counties and states queries. This gives us the matching state and county name for each GeoID. The state ID is the first two characters in the GeoID, and the county ID is the last three characters of the GeoID. Each state has a unique FIPS code, but the county IDs can replicate over several states. It is important then to use both of these IDs as the 5-digit GeoID code to map the state and counties. The GeoIDs also map up to the metro areas because large metro areas can contain multiple counties within them. Now we see separate queries for the state inflow and state outflow immigration numbers for the IRS data. The inflow numbers we see are positive numbers because these are people coming into the state, and the outflow numbers are negative numbers because these represent people leaving the state. Both these data tables contain the state FIPS keys, which we map up to the two state FIPS keys that we also see in the query editor. There are two FIPS code tables because the migration patterns have a start position or state and an end position, which is another state. And we want to use both of them in some of our visuals we will create later in the course. One of them I labeled as main reference because that is the lookup key we will connect our population data to and their main point of state FIPS reference keys. If you want to learn more about how Power BI works on the back end, check out my Power BI Data Methods course in the library. Lastly, notice that because we are not going to use the two separate queries that go into the total population numbers, we can right-click on the query name and select to not enable the load. Our last step is simply click on the button at the top to close and apply and load our data into Power BI. When we load the data into Power BI, we first see the report view of Power BI, where we see the data tables we loaded from our query on the left-hand side of the screen in the field section. This view is where we will create our visuals and dashboards. In the upper left corner, the icon below the report view is the data view. Here is where we can view our data tables and filter them as we like. The last view is the model view. For those of you familiar with Microsoft Access, joining tables in Power BI is very similar to joining tables in an Access database, in that we connect the related tables. As long as we are not connecting dozens of tables, joining tables in the model view of Power BI can be a much smoother endeavor than merging the queries in the query editor. It can also make it much easier to potentially add other sources later in our Power BI model. We already have several connector lines automatically set up between our tables. I would recommend putting data tables at the bottom of the page. So we move the U.S. population data table to the bottom of the screen. We can also resize it by clicking on the bottom right-hand corner of the table and expanding it out so we can see the entire title. We also move the inflow data table to the bottom of the screen, and we put the outflow data table right next to it. Now disconnect the year 1 state FIPS from the GeoID table. We right-click on the connection and select Delete. We will discuss more about connecting to the year 1 state FIPS key later in this course when we use visuals to analyze the flows between the states. We see that we already have the GeoID for the counties and states connected to the U.S. population data. We place it above the population data to indicate that it is a lookup key. Now connect the GeoID for counties to the year 2 state FIPS key, and we're going to check that we've set this up as we anticipate. We are going to use the state FIPS for both of them and hit OK. And let's do the same for this line as well. Now we see that we've already have the GeoID lookup key connected to the metro areas lookup key. Because the metro areas table is a lookup key of the GeoID, we want to place it above the GeoID table. Notice the arrows between the tables point down to the data tables, indicating those fields and their values flow down to the data tables. For this project, I am only going to use one-way arrows for the data connections. Even though Power BI supports many-to-many connections and both directions for cross-filtering, doing this would otherwise complicate our model and potentially cause issues later. One issue we see here is that we want to see the metro areas as a lookup key to the GeoID. So we need to change the direction in which the key works. We double click on it and we change this to one-to-many and hit OK. We now see the arrows pointing in the direction we want it to. Now connect up the state inflows for year 2 to the year 2 state FIPS table. We click on the year 2 state FIPS and drag it to the state FIPS code. Double click to confirm we're looking and matching the same fields. Hit OK. And for the outflow data, we want to connect up the year 1 state FIPS key to the state FIPS code. The reason for connecting the year 1 outflow to the year 1 state FIPS is that we want to measure the number of people leaving the state, and we want to line this up so that we see that they were in that state in year 1 and they moved somewhere else the second year. So we do the same thing where we drag and connect the two tables. Now we connect up to the year table. Move it over so we can see it. We connect the year field in the population data to the year's lookup key. The reason we do this is because we want to connect to the migration data as well. We then join the state inflow and migration. We choose the year 2 and we join that up to the years table. We move it around so that we can more easily see the line connections. We also do the same for the outflows as well because we're measuring this over the same time period. Again, we drag the year 2 to the years table. By setting it up this way, this allows us to perform analysis over the same time period and using a uniform name for the state. If you would like to learn more about setting up relationships between data tables, you can check out my Power BI Data Methods course in the LinkedIn Learning Library.